The solution is built with three classes, one to handle the transaction data, one to handle the ledger block, and one to handle validation of blocks and the entire blockchain. We'll start with the transactions, handled by the ledger transaction class. All of the classes will be defined as without sharing. This is unusual, but essential for this application. The blockchain code must have full access to all of the fields and records in order to be able to correctly calculate hash values, maintain blockchain integrity, and validate the entire blockchain. In fact, we'll be using Salesforce Object and Field Security to prevent users from accessing records, and it would be quite reasonable for organizations to use sharing rules to restrict who can view various ledger transactions. We call this delegated security, where the blockchain code has greater permission to access data than the user account invoking the code. Not only are these classes marked as without sharing, they intentionally ignore object and field level security. This won't matter for most situations, but if you decide to implement this approach in a managed package intended for the AppExchange, you'll need to explain and justify this approach to the security review team in order to pass the AppExchange security review. The ledger transaction class has a single constructor that takes the ledger entry object. It can be a new object, in which case the class will be used to calculate the transaction hash, or an existing object, in which case the class will be used to validate the data against the transaction hash. In either case, the class will need a list of the fields that are part of the transaction, that are included in calculating the transaction hash. For new records, the list of fields to use can be defined in a variety of ways. I have it hard-coded here in the getNewFieldList function, but you could store them in custom metadata or a custom setting. You wouldn't want to use every field. For example, the owner, last modified time, and record name shouldn't be used, as they are bookkeeping fields that you would want to be able to change without impacting the validity of the blockchain. I already mentioned why you would not want to use lookups or formulas. The transaction field list and transaction date are also considered transaction data, so they are added to the list of fields as well. Next, we validate the field list. Every field is checked to see if it is a valid field. It is also tested to make sure that it is an acceptable data type. For this example, that means any data type other than lookup or formula. If any of the fields aren't valid, we return null to indicate that the field list itself is invalid. For existing records, the getValidatedFieldList function pulls the list from the stored transaction field list. It is very unlikely that any of these fields would be invalid. That would only occur if someone deleted a field or tampered with the transaction field list entry. In either case, the transaction validation will fail. But we don't want it to fail with a SQL query error, so the fields are validated to make sure they all exist. If not, the function returns null, indicating that the transaction is invalid. The getTransactionHash method is used for both new and existing records. It takes a specified field list and builds a string by concatenating all of the transaction data fields. Decimal fields are cast into a double to avoid false validation errors if the number of trailing zeros after the decimal point varies, which I've seen happen. It's very easy to calculate a hash value in Salesforce. First, you convert the string into a blob. That's a block of binary data. Then you use the crypto.generateDigest function to calculate the hash using the SHA-256 hashing algorithm. The hash is stored in a 256-bit blob, that is, 32 bytes of data. The base64 encoding is an efficient way to represent any binary data as a string, so you use the encodingutil.base64encode method to return the hash in base64 format. The setTransactionHash method is called for new records. If the field list returned from getNewFieldList is valid, it stores it in the transaction field list field, stores the current date time in the transaction date field, and sets the transaction hash field to the hash value calculated by getTransactionHash. The isTransactionHashValid function is used to verify an existing transaction. If the getValidatedFieldList function returns a valid list of fields, it calculates their hash value and compares them to the stored transaction hash field, returning true if they match. As you can see, setting and validating the transaction data is very simple. As you'll discover in the next clip, setting and validating the entire block is almost as easy.